All right, as we're winding down the year, we're going to start talking about some statistics. And today, our notes are on scatter plots. Central question is, what are the inferences that can be drawn from sets of data points? So go ahead and make sure you get that down in your notes. And having a positive association and a negative association. Okay, so what are the inferences can be drawn from sets of data points having positive association and negative associations? And so you're going to learn about each of those as it pertains to scatter plots. So what is a scatter plot? Well, it shows a relationship between two variables graphed as an ordered pair. Okay, let me give you some examples of what scatter plots look like. So as the definition states, it's the relationship between two variables graphed as ordered pairs. So here's a variable, average daily temperature, and the number of visitors. So two different variables, and it's how they relate. So you can see here as the temperature rises, or as it gets hotter, there's more and more people that go to the beach. Here's something about snowboarding competitions. As the years progressed, there was more and more participants. So that's a scatter plot. This is fitting since we're talking about test taking. The hours of sleep that you get, right, as you increase the number of hours, the higher your test score typically becomes, but it's not always the case. And then we'll see other types of scatter plots. Here's another one, reading scores and writing scores. You can see that the dots are kind of all over the place. And finally, just some other examples of scatter plots that you're going to see. You're going to see maybe dots all over the place. Maybe you see them kind of creating some kind of pattern of some sort. And we'll be describing all those today. Let's get started with an example. Here's some television ratings on a particular TV show, okay? Season 1 through 6, and the number of viewers. So in the very beginning, 31.7 million. This is all in millions. And then they changed as the seasons go on. So what we do is we're going to take this as two variables. This is seasons and this is viewers. And what we want to do is we want to create a graph. So that's what we're going to do next. Okay, so my graph below, let me just scoot this up. What I did here is I went in and graphed each of these points. You can see that season 1, 31.7. So I start off with my seasons on the bottom, 1 through 6. On my y-axis was the viewers in millions. And notice I have this little break in the graph. It tells you that, hey, there's more numbers that go beyond, but I'm going to start way up here because all of my numbers are at least bigger than 20. So that's why I started with the lowest number, 20. Anyway, so it's year 1 was 31.7. So I kind of put that there, and then I graphed the rest of them. Okay, so I start off with creating that. This is a scatter plot. Here's another example. The speed at which you drive, miles per hour, 20, 30, 40, all the way through 60, and the distance that it takes you to stop. So in a car, you're driving 20 miles an hour. It takes you about 42 feet to stop. So if you slam on the brakes, 42 feet to stop. If you're going 30 miles an hour, it takes you 74 feet to stop. It goes all the way up to 60 miles an hour. So you can see why it's important later on when you start to drive that you give yourself gap. If you're on the freeway, you got to give yourself some space in between the next car because it's going to take you about 248 feet to stop the car. So what we do is we go ahead and graph this and create a scatter plot. Okay, so on the bottom here, my speed goes from 0 to 60. And because my numbers are kind of varied, I can start at 0. And I just go by 50s here, 50, 100, 203. And then I plot them, and I can start to see that. Okay, you can start creating relationships, kind of look at this and say, wait a minute. As the speed increases, so does the distance. And that makes common sense, right? So yeah, okay, going faster, it's going to take me longer. And this is in feet over here. It's going to take me longer to stop. So now I want to know how I'm going to describe these relationships, right? The type of associations. So the first thing we're going to talk about is the variable association. Okay, so how are the variables associated? There's 3 different ways you can say. You can say, look, they're positive association, negative association, and no association. So if the points that we start creating start to create a line, right? They start to be kind of clumped together and they're going in one general direction. We can say that's a positive association, like a positive slope. If the points we're starting to plot start to create like a negative line, if you will, we can say it's a negative association. And then if the points are like all over the place, say they're not associated, it's not correlated, there's no relationship between the two. And then the other 2 ways you can describe this is, hey, do they have linear association? Are they linear? Right? Does it kind of create a straight line? Right? Or are they not linear? If you notice here, it's kind of all over the place. So no, it's not linear versus yes, this is linear. And they don't all have to touch on the line, but they're starting to create kind of a pattern that looks like a line. So you can analyze the shape of the distribution of a scatter plot by looking at the patterns or looking for patterns. Okay, so is it positive? Is it negative or none? Is it linear or not linear? So let's take a look at this last example I'm going to give you today. Last two words you need to know about are called clusters and outliers. Okay, clusters, if you notice, if I were to plot some stuff, I notice that a whole bunch of points are close to each other. That's considered a cluster. There's something unique happening in this area. And then there's an outlier. So look, not all the ways does this work out, right? It's like, oh, there's somewhat of a pattern, but there's this outlier. Something's kind of standing out, if you will. So we're going to interpret the scatter plot. All right, this is our last example. If I were to give you something like this, okay, memory gigabytes. So this is like an MP3 player. As the memory increases at an MP3 player, the cost, these are the different costs. So I can see here that there's like a cluster here. Look, the costs for MP3 players that have 1 or 2 gigabytes of memory, they all cost about this much. They're kind of clustered together. And then I've got another type that have a lot more memory, and they're kind of clustered together. And I could say that maybe even this one here is an outlier. This one here, like, look, this has got 8 gigabytes of memory like everybody else, but it's way more expensive than everything. Maybe some kind of name brand, something that people are willing to spend more on. And so you can explain that. Say, hey, look, generally speaking, like they're kind of like here, this is a positive correlation. As the memory increases, so does the cost. And then, of course, there's an outlier over here. All right, that's it for notes today.